Assalamu alaikum everyone. Today we're solving a question on similar shapes. Let's get started. The question states A, B and C are three solid spheres. Sphere A has a volume of 64 centimeter cubed and sphere B has a volume of 125 centimeter cubed. So I'm going to pause over there. In this part of the question, right, it's giving me the two volumes. So at this point I pause and I then find the scale factor of the volume for these two shapes. So scale factor of volume, or I can even have them as ratios if I want a ratio. Yep. So because the question later on goes for ratio, I'm going to try and do it as ratio. So volume ratio for A to B, I'm going to number this. That's number 1. That's where I'm starting my question. So the volume ratio, A is 64 centimeter cubed and then B would be 125 centimeter cubed. So from this volume ratio I can work out the length ratio by cube rooting the volume ratio, because the volume ratio is 3-dimensional and the length ratio is 1-dimensional. So if I cube root it, I'll get the length ratio. So cube root of 64 is 4 and cube root of 125 is 5. So the length ratio for A to B is 4 to 5. Okay, now I'm going to carry on reading the rest of the question. The radius of sphere C is 50% the radius of sphere B. So sphere C, its radius is 50% of sphere B. So it'll be half of this really. Work out the ratio of the surface area. So I can say B to C, right, would be, let's say this. So if this was 100, this would be 50. So processing that, number 2. So I can simplify this, let's say divide by 50, divide by 50, it's 2 to 1. Now, you see the problem I'm having now is B is 5 in this ratio, the length ratio, and this is a length ratio too. And B, the value for B is 2. So what I'm going to do now is to make things easier for me. I'm going to make the two length ratios in such a way, I'm going to change it so that the value of B is the same in both the ratios. To do that, I'm going to multiply this by 5, so it becomes 10. That's because this number is 5, and I'm going to multiply this number by 2, so it becomes 10. And to maintain the equivalence of the ratio, I'm going to multiply this by 2. So the length ratio from A to B becomes 8 to 10, and the length ratio for B to C becomes 10 to 5. Okay, now I'll carry on. So I've processed this, I've processed this, I've processed this. Work out the ratio of the surface area of A to the surface area of C. Okay, so what I'm going to do now is I'm going to write down A to B to C. All together, I'm going to write down the length ratios. So A was 8 parts, B was 10 parts, and C was 5 parts. Now the area ratio for this would be found by squaring all the lengths. So 8 squared to 10 squared to 5 squared. And the reason for that is the area is 2-dimensional. So to get from the 1-dimension length ratio to the area ratio, you'd have to square. So that'll be 64 to 100 to 25. So it wants the surface area of A to C. So A to C area ratio will be 64 to 25. And we can't simplify this ratio any further, so we stop there, and that's it really. Hope this helped. Thank you for watching.